Today we're going to be talking about how calculus is related to pharmacy, and we're going to approach it with the pharmaceutical companies and how they can maximize their profit. And then we have P, right?
Mm-hmm.
And P equals
P is
R minus C.
R minus C, yeah.
P of X.
Mm-hmm.
R of X minus C of X.
Mm-hmm. Yep.
I think that's it, right?
Yeah, I still don't get it. Like, what does this have to do with pharmacy? I'm completely confused.
To answer your question, we're going to take the approach of a pharmaceutical company and how they can maximize their profit. And that's how calculus can relate to a pharmacy. And so we're going to use variable X. Now that's going to represent the thousands of bottles we are selling. Rx represents the revenue. And we're going to use 10 times X. Every 10 is the thousands of bottles we are making. And so then our profit is going to be our revenue minus our cost, of course. So from here, we're going to start finding how we can maximize our profit with related rates. Alright, so we're just going to wait on our consultant, Dr. Brian, to come in and give us a formula that can help us calculate our cost.
Say that again.
So anytime now, he'll let us know what the cost is. Bro, it's not over, bro. How you doing, Dr. Bryant?
I'm good. How are you?
I'm good. You got the formula?
Yes, sir.
Alright.
Let's see. After various statistical analyses with my panel and I, we've derived this formula. Negative 4x squared plus 432x minus 3,197.
Alright, and from this we can find our profit, which is going to be P of X. That's going to equal our revenue minus our cost, C of X. And then so we're going to use the formula Dr. Brian came up with, and we're going to first find a derivative of this. You want to do it, Doctor? You want me to do it?
I think I got this.
Alright, then.
So, to find the derivative, this function right here, we get 8x plus 432.
Alright.
And this has no derivative.
Yes.
It's just a whole number.
And so all he has to do now is solve for X.
So to do that, I'll set it equal to 0. And then I'll move the negative 432 to the left. Now someone get a calculator.
Alright, I got you. So,
Divide the negative 8, and we get that x is equal to
54. Okay, so what we need to sell each bottle at is $54, and that's going to maximize our profit. And that is how calculus is related to pharmacy.
Well, that makes complete sense now. I was completely overthinking it. Earlier, I was definitely confused.
So what?
Wait, I gotta run down what y'all did.
You can come up on the board.
Oh, okay, I'm gonna come up to the board. So, we took the formula given to us from Dr. Brian
Right.
for the cost.
Right.
And basically took the derivative of that.
Yes.
And we set it equal to 0.
Mm-hmm.
We brought the 432 to the other side, divided by 8 to get x by itself, and now the maximum profit is $54.
Yep.
I don't even know why she tripping. It's the easiest subject.
So $54 is the maximum.
That is what we need to sell our bottles at to maximize our profit.
So each bottle should be $54 a piece.
Yeah.
Basically.
The next day.
Run.
Dr. B! Dr. B! Is he home? Dr. B!
Oh, hey, what's up, man?
We have
A code 9.
Math-tastrophe?
I'm sorry to say, but you made some errors. But I've come to help you fix it.
Well, don't just sit there. Come on. Come on. Let's go fix this.
Remember how you said that yesterday you were working with that teacher and student and y'all were trying to figure out the maximum profit? Well, I've come to help clean up the situation a little bit. You guys weren't using related rates to help you solve the problem. You were actually using the economic standpoint of applied optimization. Well, can you show me what you guys came up with so I can see where I went wrong? Of course, Dr. B. I'll do everything I can. Now, if you take a look with me.
In order to find your maximum profit value, all you had to do was set the derivative of your revenue function equal to the derivative of your cost function. And these two functions equal to each other would yield the derivative of your profit function, and that would give you your maximum profit.
But why are we going over this? I mean, we're not even a calculus teacher or the student. We're pharmacy consultants. Well, somebody's got to learn it. Can't believe I mean, how could I not have seen this?
Maybe it's because of them dark specks you call glasses you keep trying to see through.
I resent that. I can see just fine. Dr. B, it was a pleasure visiting. Glad I could clear that up for you. Yeah. You too. See you, Dr. B. See you.
There must be some magic clue inside these gentle walls. 'Cause all I see is a tower of dreams, real love bursting out of every scene. Days go by. It's the bigger love of the family.